are considering a topic, cell. Some people, the first thing that may come into their mind looking at cell, they will look at that in biology, which is the smallest unit of a system. But in physics, it's different thing entirely. So what we mean by cell is that device that converts chemical energy to electrical energy. A device that converts chemical energy to electrical energy. So this is example of a cell. This cell converts chemical energy to electrical energy. You know, inside this battery it has chemicals. So you connect a bulb to this, you can see a light. So we say that a cell is a device that converts chemical energy to electrical energy. And the single unit of this cell is what we call electromotive force. Single unit of this cell is what we call electromotive force. And if you are asked what is a battery, battery is combination of two or more cells. If you combine more than two cells, give you what we call a battery. Is that okay? While a cell is a device that converts chemical energy to electrical energy, and the battery is the combination of two or more cells. Is that okay? Then we now look at what we call electromotive force. Electromotive force. Electromotive force. EMF. Electromotive force. So when you look at this battery, before you connect this battery to anything, then what the battery has is what we call electromotive force. So this electromotive force of a cell is potential different across the cell when the cell is not delivering any current to the external circuit. It's not delivering any current to the external circuit. Then we say is what electromotive force. It have that potential that it can transfer, or it can give energy. Is that okay? But if it is not connected yet, we have what we call electromotive force. But if you connect this battery to external circuit, let's say a bulb or any other thing, then we have what we call potential difference. And we have a terminal potential difference of a cell. This is the potential difference of a cell when the cell is delivering current to the external circuit. So when you connect this battery together and there is light on this battery, then that is called terminal of potential difference. But if this battery is only there without connecting it, what the battery has is electromotive force. But it has the ability. Is that okay? But you know that this battery has a resistance in it. The terminals, these are the terminals. This is The down one here is the positive terminal, while the up one here is negative, positive terminal and negative terminal. And this battery has a total value of EMF, which is 1.5 volt. So when we combine two cells now together, it gives us 3 volts. The total EMF of this battery is 3 volts. So you know that if you connect this battery to some load, you connect it to ammeter, voltmeter, resistor, and other loads, wires, there is what voltage drop across all these materials you connected to. So then at the end of the day, what you have is potential difference. So can we differentiate between potential difference and electromotive force now? Why is electromotive force greater than potential difference? Because in electromotive force, no current is delivered, while this one, current is delivered, and there are voltage drops across the circuit. So we won't expect to see that we have the same value, because there are what? Voltage drops across the cell. And we have what we call what? Loss volt. So, okay, I've not defined what we call internal resistance. As I say, internal resistance, you know, in this cell or battery, it has internal resistance in it. So that is what the opposition offered by electrolyte of the the flow of current. Opposition offered by the electrolyte to the flow of electric current. This and this rod here, we have what? Electrolyte. So the opposition offered by the electrolyte to the free flow of electricity or current in this cell is what we call internal resistance. Within the cell itself, there is what? Resistance. That is why sometimes we say, even you yourself, there are certain things, there are certain opposition going around you, not even other people from outside. So even the battery too has that. Is that okay? Good. So we say internal resistance is the opposition offered by the electrolyte of the cell to the flow of current. And we have defined potential difference of the cell. We have defined EMF of the cell. So I hope you people understand very well. You know the difference between the EMF of a cell and the potential difference of the cell. Then why is EMF of the cell is greater than potential difference of the cell? Because there are voltage drop across the circuit when the cell is connected. So we hope to see more of this in our next class. Thank you.